everyone. So, before starting the ML workshop, I'd just like to ask a simple question. What interested you guys in machine learning and why did you exactly join this workshop? Just write your simple answers in the chat box so I can get to know that what interested you guys. Anyways, so moving ahead, I'll just start with what exactly is machine learning. So to put it simply, machine learning is just the science of getting computers to act without being explicitly programmed. So as you all know that any computer or any machine is just a dumb device. To get even the simplest of outputs from it, we need to feed it with loads of input and guide it in every path. So what machine learning basically does is, it allows the machines to learn from past experiences or patterns so that it can learn itself and provide outputs without any difficulties. Now, as you all know that this complete era is of AI and ML, that is Industry 5.0. So now we'll be beginning with the different types of learning that are needed in machine learning. So first, we'll start with supervised learning. In supervised learning, what we do is we provide the model with input as well as we also tell it what we need as an output. That is the target variable. I'll just give you a simple example. If we need to predict the price of some houses in a locality. So in input, we'll give it the square footage of the house, the number of rooms, the locality, etc. So all these are the input variables, and the house prices are the output variable, that is the target variable that we need to predict. So this is a very simple example of supervised learning. Now moving ahead, unsupervised learning. So as the name suggests, the only difference between supervised and unsupervised learning is that in unsupervised learning, we do not provide with what we need to get as an output. The model itself identifies certain patterns or groupings within the data, and it find out the patterns so that we can get an output. A very simple example of it is, if you consider a fruit basket, उसमें एक like apples हैं, bananas हैं, or oranges हैं. So a model which just detect these patterns and segregate each fruits accordingly. This is a simple example of unsupervised learning. And some other places where unsupervised learning is used is recommendation systems or spam detection. Now moving ahead, the next part is reinforcement learning. So reinforcement learning is quite unique because here we neither provide with the input nor the output to the model. So what we do is, here the model just interacts with the environment, and based on a policy system through trial and error, it receives rewards by certain actions and also penalties by certain actions. और उनसे वो सीख के पता करता है कि क्या एक्शन करने पे we get a reward और क्या एक्शन करने पे we get a penalty. And reinforcement learning is very much used in gaming simulations, and also you can understand by एक 2 साल का बच्चा है, वो चलना कैसे सीखता है. First he or she starts crawling and then moves ahead to start walking and so on. So this by this you can get a relationship between reinforcement learning. So guys, this was the part for learning part between of ML. So if any of you has any doubt, just please raise your hand, or if there are no doubts, just give a thumbs up so I can move ahead.
Yes, Pratik Kuntia has a doubt, so I'm unmuting you.
Whether interacting with a certain object is beneficial, will it provide a reward, or is it bad, that will it provide a penalty for the model. So through this iteration of trial and error, it figures out what is correct and what is wrong. As you can see in this image, see, this is the agent, this is the model, and this is the and the water tap and the fire are the environment. So if it touches the fire, it has a bad impact. It has a bad impact. So it will figure out that it is a penalty. So to avoid it, it will go to the water tap. So this is the simple example of reinforcement learning. So is it clear for you? Okay, so are there any more questions? Okay, so I'm moving ahead. So till now you have heard me saying input data, and each form of learning. So what exactly is this data and data set? So there are actually three types of data set in any training any model, that is training data set, validation data set, and test data set. So first we'll learn about training data set. So this training data set is actually the very important part for any model, because the complete learning process and the complete training of any model is done through this training data set. In this training data set, we provide with certain data sets according to our need, and the model is trained accordingly. Next, validation data set. So in validation data set, it is used during the training process to fine tune the model's hyperparameters and prevent overfitting or underfitting. Now, here you have heard three new terms: hyperparameters, overfitting, and underfitting. So let me explain you each of them. So first, hyperparameters. So these hyperparameters are actually parameters that are explicitly defined by the user, that is the machine learning engineer, before the learning algorithm begins, to control the entire learning process. So these are values that cannot be changed during the learning process. So that is why hence they are called hyperparameters. Now underfitting and overfitting, they are quite similar. See, underfitting means when we provide the model with less amount of data that is not enough for it to predict the output, so the model's accuracy decreases. Similarly, overfitting is when we provide the model with too much of data, so it starts getting confused with too much of noise and inaccuracies. And because of this also the model's accuracy decreases. So in validation dataset, we try to prevent all of these. And this validation dataset is actually used to evaluate a model. Like if we start training a model and we have completed its training. So to evaluate it, whether it is good enough to be finalized or not, we use this validation dataset. So see, this validation dataset never teaches the model anything. The model never learns from this. It is just used as a evaluation tool. Now, the test dataset. So after the going through several iterations of validation dataset, we get a finalized product, that is the final model. So this test dataset is used to accurately check whether this final model is good enough or not. Because in this test dataset, the datasets are completely different from the training dataset and validation dataset. This test dataset is very well curated and has carefully sampled data. Now the division between these datasets is done quite simply. First, if we have a dataset, we divide it into two: train and then test. Now we take a certain percentage of trained dataset and convert it into validation dataset. And through several iterations, we just train the model and evaluate it through this train and validation dataset. And this process is known as cross-validation. Now, so do any one of you have any problem or any questions in this part? Any questions or any doubts? If not, just give a thumbs up so I can move forward. Okay, looks like there is no issue. Okay, there is one issue. Okay, so there is no issue. So I'm moving ahead. Now we'll be learning about different learning techniques used in machine learning. So here we'll be discussing about three of them. That is clustering, classification, and regression. First, clustering. As you can see that clustering is a part of unsupervised learning. So in this, I gave an example of fruit basket. Similarly, if you can take an example of group of animals. There are a group of animals and some have certain similarities, some have other similarities. So through clustering, we can segregate each of them based on their similarities. This is known as clustering because we don't know exactly what output we'll get. We are just segregating based on their similar patterns or similarities. Now, classification. Classification is a part of supervised learning. Here, we know what will be the output. but here the output will be in a class form. So like for example, अभी जैसे सबके एग्जाम्स आने वाले हैं, रिजल्ट की चिंता तो सबको होगी. So if we use a classification model to get the result of any student, so it will just tell us whether the student is pass or fail. It will not give us the exact quantity, whether we are pass, what marks we have scored, or what percentage. And now regression. So the difference between classification and regression is that in regression we get a continuous numeric value as an output. Like if for the same question of result of a student, in using the regression model, we'll get an exact percentage, exact numeric value, what score the student has scored. And this is the difference between classification, clustering, and regression. So any issue or any question from this part? Guys, if you don't have any questions, please interact, because this is an interactive session and it is just the building blocks of machine learning. If you have any questions and you are not asking, then you will face problems further in the workshop. Are there no questions? Okay, Prateek, you have a question. So we'll just unmute you. See, regression just basically means modeling a relationship between independent and dependent variables. And I also gave you an example. There is nothing extra to tell about. Are you confused in any concept? You can ask. And we are your seniors, so don't need to greet us with sir. You can call us bhaiya only. Okay, there's no problem. Ayush, any other issue? If not, just give a thumbs up so I can move ahead. Okay, so I'm moving ahead. Now, as you can see, this straight line is known as best fit line or the line of regression. And our job in this algorithm is to minimize the difference between the predicted value and the actual value of the output. And which this difference is known as random error. Okay, so our difference is to minimize it. Also, there are multiple types of linear regression as well. That is a simple linear regression, as I told you, and there is also a multiple linear regression. So, as you can see this example, and these beta naught, beta 1, beta 2 are known as regression coefficients. So what is the importance of these regression coefficients? So you can see here equation is there, y equals 1.104 plus 0.154 x1 and so on. So what these regression coefficients tell is how much impact or how much important all these features that are x1, x2, x3, these independent variables are in predicting the value, the output independent variable y. For example, again I am taking the example of result. So in the result y is the result, and here let me take x1 as roll number and x2 as percent. So tell me what according to you guys will have higher regression coefficient? Come on, quick, very simple answer. X1 is roll number and x2 is the percentage in calculating the result. So which one will have higher regression coefficient? Any answers? X1. Okay, we have one answer. Abhirup, can you give me the reason why do you think X1 should be the should have higher regression coefficient? X1 was the roll number and X2 was the percentage. ऐसे random तुक्का नहीं मारना है. If you have an answer, just give a reason, proper reason. Write it up in the chat box. See guys, if you can't answer this question, that means you have not understood the topic of regression coefficient. So if you have any questions, just ask. I am there to help.
Dhruv, are you able to unmute yourself?
Okay, so just write it up in the chat box. Okay. See, you thought there are a lot of, see, here, in predicting the result, roll number is not that important as the percentage. So obviously the percentage, the X2 will have a higher regression coefficient. It will, because it will create a higher impact on predicting the result. So understood? Is there any question from this part? Okay, so just give a thumbs up so I can move forward. Okay, cool. So now moving ahead. See, as I told you, the difference between the predicted and the actual value is known as error. And when we form this error in a form of a function, that is mean squared error, this is known as cost function. And this cost function is really helpful in predicting, minimizing the errors and increasing the accuracy of the model. And to do so, we use another algorithm, that is gradient descent. See, the graph of the cost function with the value of regression coefficient is a parabolic. As you can see, it has the power 2, so it is a parabolic equation. So in gradient descent, we iteratively move along the curve so that we reach the point where the difference between the cost function and the value of beta, that is the regression coefficient, is minimum. If we move further ahead, we are moving in opposite direction of the descent. So that is why this is wrong. So this is the use of gradient descent and mean squared error cost function to minimize the difference between the actual and predicted value so that we increase the accuracy of the model. So any doubts, any problem in this part? See guys, this is a mathematical part, so if you have any issue, please ask, because these algorithms are the building blocks of machine learning. Okay, so see, did you understand this graph between the cost function, and the value of regression coefficient? This is parabolic, right? So in gradient descent is an algorithm where we iteratively just you can consider it as iteratively differentiating this function so that we can get to a point where the difference between this cost function and the regression coefficient is minimum so that we can decrease the level of accuracy. So Pritanu, did you understand this part? Okay. So any other doubts from anyone? See guys, you will also have a quiz at the end of the workshop. So please make sure that you understand every concept clearly. And if you have any doubt, please ask. This is an interactive workshop. बस मैं बात करने नहीं आया हूँ. तुम लोग कुछ भी सवाल है तो पूछ सकते हो. No issue? Okay, perfect. So I am moving ahead. So this was all from the machine learning part. So now I'll be handing over to Lakshanya to introduce you to deep learning.
So hello guys. So right now we have covered machine learning. I hope everyone understood everything. And guys, please use the reaction or raise your hand so that we get to know that you guys have understood stuff. Like there's an option below called send a reaction. Like send a thumbs up or raise your hands if you understood something. Please be interactive. So according to the itinerary, next topic is, Rishabh, do you have a doubt or are you just reacting that you understood? Use the chat box as well, okay? So I'm going to start. Introduction to deep learning. AI and deep learning has been revolutionizing so many different areas of science, maths and physics. Not that long ago, we were facing new types of challenges and problems that we did not think were necessarily solvable in our lifetimes, that now AI is actually solving. even beyond human performance. Isn't that fascinating, guys? Send like a thumbs up or anything. So AI is now generating content with deep learning being so commoditized. Deep learning is in all of our fingertips, online, in our smartphones, etc. Just a minute, guys. I was telling that AI is now generating content with deep learning being so commoditized. Deep learning is in all of our fingertips, online and even in our smartphones. In fact, we use deep learning to generate these types of hyper-realistic images or media entirely from English language, even without coding. So before, we actually had to go in, train these models and really code them to be able to create a hyper-realistic media. Today we have models that will do this for us from end to end directly from English language. So we can prompt these models to create something that the world has never seen before, like a photo of an alien riding on a tiger. These models can imagine those pieces of content entirely from scratch. Like, have you guys ever done this, like made weird pictures or use like ChatGPT or Meta AI to create your pictures? Yes, okay. Isn't that fascinating? Was this available a few years ago? No, right? See, that's how much we've come far. Probably a thing that all of you do in your CS labs is how we ask the DL models to write a piece of code. It even walks you through each part of the code, so it's just not producing the code but actually educating you and teaching you on what each part of the code of block does. This is how far DL has come. So guys, this was the introduction. So let's move on to what is deep learning. To understand deep learning, we will have to start from the very beginning by asking what is intelligence. I'm sure everyone of you here are intelligent, but have you ever wondered about the question, like about the definition of intelligence? How is it defined? Intelligence is simply the ability to process information which will inform your future decision-making abilities. That's something we as humans do every day, don't we? You predict, will class get cancelled today? Will it rain today? That's basically what you do. And that's basically what we are teaching computers to do as well. Now, AI. AI is the ability for us to give computers the same ability to process information and to inform future decisions. Right? Now, ML is simply a subset of AI. As previously discussed, you guys already have a brief idea of ML. So you will know what ML is. So ML is a science of trying to teach computers how to do the processing of information and decision making from data. Going one step deeper, deep learning is simply a subset of machine learning, which uses neural networks to process raw pieces of data and information to inform future decisions. Guys, did you understand what is AI, ML, and DL? Please give a thumbs up or just text a yes in the chat box. Yes, thank you. So I'm moving on. Why deep learning? So ML typically would define a set of things to look for in an image or a piece of data. These are hand engineered, so humans will have to define these themselves. So what is the problem here? The problem here is they tend to be more time consuming, brittle, and not scalable in practice. When we have computers that can do this for us, why would we humans waste time on it, right? So the key idea of DL is this paradigm shift of trying to move away from hand-engineered features and rules that computers should look for, instead trying to learn them directly from data. Yes, AI can do it super fast. So I'm taking an example here. If we wanted to learn how to detect an image of a clock, you will be looking for some particular patterns like minute hands, hour hands, second hands, numbers, dots, Roman digits. Aren't these the features of a clock? So you'll be looking for it. When all these things are composed in a certain way, you'll probably deduce that's a clock. Computers do something very similar. So they understand what are the patterns that they have to look for. Those are numbers, minute hands, hours hands, second hands, and then predict them. So these algorithms have existed for many, many decades. So the question is, why are we studying this now? And why is it blowing up now? Have you ever wondered why is now you see everyone's ML workshop, DL, why is it doing it now? Can you go to the next slide? Yes. Next slide, please. Yeah. So why now? Why is it blowing up now? Number one would be the data available now is significantly more pervasive. That means the models are hungry for data. The data is more abundant than it has ever been in history. Second one would be these algorithms are parallelizable, which means they have greatly benefited from compute hardware, which is also capable of being parallelized. The particular name of the hardware is GPU. Can you see a device there? That one is called GPU. It's a graphic processing unit, similar to CPU, but it's more advanced, more quicker. And this is a main component for DL. So GPUs can run parallel processing streams of information and are particularly open to DL algorithms. And the abundance of GPU and compute hardware has pushed forward what we can do in DL. Number three would be software. The open source tools that are used in the foundation building blocks are deploying and building all of these underlying models. So, moving on, what is exactly a fundamental building block of deep learning? So, to make a learning machine, early computer scientists looked for clues by studying other things that are good at learning. And turns out nothing is better than the human being. Aren't we the superior beings? We must feel so proud that we are able to process information and do all of this stuff just using our brains. Our brain is made up of special cells called the neurons. All of you guys would have heard what a neuron is, right? You guys must have had biology in your schooling, so you know what a neuron does. So I'm going to give you a brief explanation about how neuron and artificial neuron are dependent here. So a neuron has two ends, where input signals enter from one end and are combined together inside the neuron and leave the other end as a single output. All of these billion neurons in your brain are connected to each other. That is called a biological neural network. It's how our brain processes information and recognizes patterns. So early AI scientists decided to mimic these human neurons by making their own simple artificial neuron in software. So it's just multiple signals going in as inputs, passing through the neuron, getting combined and processed by some simple math into a new output signal. It's a good start, but one neuron alone doesn't do much. The full potential of this idea is only unleashed when the artificial neurons are connected to make an artificial neural network. This allows computers to recognize patterns, drive cars, etc. So what is a neuron or perceptron? Neurons are also called as perceptrons, okay? So to understand what is a neuron, let's build a music recommendation system that uses critics' reviews to guess how much you like a song, and then we'll use your feedback to make the system better. So please pay attention. This is like the interesting bit of the session, and be interactive here. Please use your emojis and all. So here are three emojis. Three people, critics. The first one's name is Harry, who's in orange, and the green one is James, and the blue one is Lily. Okay, I've named these people as that. And these people, each of them will rate a song anywhere from 1 to 5 stars. Now let's build an artificial neuron. Each of these critics ratings enter into the input side, some calculations are done, inside the neuron, and then we get a single output. Here the output is a result, like a 5-star rating. So the first song here is Feel. So everybody, I chose the song because everyone knows the song, everyone's crazy over the song. So Harry is such a boring guy, he just gave it a 1-star rating. James gives it a 5-star rating. Okay, James, we like you. And then Lily gives it a 4-star rating. At first, the critics' opinions all carry the same weight and are equally counted. As you can see, like the weight is one word. Here, that means everyone's opinions equally matters here because it's like our first input. So everyone's opinions are equally counted. So the input enters and some basic math is done inside the yellow bar and comes out as a recommendation. So the recommendation here is a 3.3 star. Now let's give it our own rating. Let's say you really like this song. You guys like this song, right? So I give it a 5-star rating. Move to the next slide, please. Yeah. So you can see you have given it a 5-star rating. So the rating you have just provided is used to train the neuron. Based on your rating, each weight of the critic's opinion will be recalculated. You really didn't agree with Harry, so his weight goes down and your ratings were closer to that of James and Lily, so their weights raises up. So as you can see, the weights have been altered in the screen. If you're paying attention, you can see the weights have been changed according to our recommendation. So let's go to the next song. Let's take a next song, Heat Waves. Oh my god, aren't you getting COVID flashbacks? This was the IT song during COVID, right? So now let's train this neuron again. Here's another song. That's Heat Waves. Here are the new ratings from our critics, and this time the neuron will give more weight to these bottom two people, and the recommendation will be an output of 3. And now let's say like it's an old song, so I've grown out of the song, so I'm just giving this a 2-star rating. So I gave it a 2-star rating, and now our rating will adjust the weights again. This process repeats over and over and over until we have trained the system to know our preferences. So next slide, please. So after doing this process for n number of times, until our recommendation matches the output recommendation, the system will be updating its weights so that we get like a proper recommendation system. Isn't this fascinating? Guys, react. Okay, so moving further, so in this example that we took, just one neuron was there. That's far more simplistic than most of the systems. So powerful neural networks have millions of neurons arranged in layers, which we will dive into in a bit. Now that you've got an idea of what a neuron is, let's talk about the forward propagation of information through a single neuron. Now a single neuron ingests information or multiple pieces of information. So here it is x1, x2, so on, xn. Each of these inputs is going to be element-wise multiplied with a particular weight. So the weights here are denoted by W1, W2 and Wm. So every weight is being assigned to an input. Now you will have to multiply the inputs with their weights together and then add them up along with the bias. Now we pass this through what's called a nonlinear activation function to produce your final output, which is y that you can see on the screen. So right now I just used a word called bias. So what do you think a bias is? So bias is basically a term. It actually allows a neuron to shift its activation function horizontally on the x-axis. So you can see it mathematically written on the screen as a single equation, and you can actually rewrite this using linear algebra, using vectors and dot products. So I think you guys are familiar with vectors and dot products. We had it during JE, right? So now our inputs are going in, denoted by capital X, which is simply a vector of all our inputs from x1 to xn, and then our weights are denoted by capital W, which is going to be a vector of W1 to Wn. The input is obtained by taking the dot product of x and w. The dot product does the element-wise multiplication and then adds them all up and applies a non-linearity, which is denoted by G here. So like in this part, I kept telling activation function, non-linearity. Like, aren't you guys like curious what it is? Like, how can you just told activation function? What is an activation function? So let's understand what actually an activation function is doing. So previously, as I mentioned, it's a non-linear function. One of the most common function is the sigmoid function. Its output, its input takes any real number on the x-axis, that is from negative infinity to positive infinity. But on the y-axis, it basically squishes every input of x in between the numbers 0 and 1. It's a very common choice for things like probability distribution. In fact, there are many different types of non-linearities that are used in neural networks. As you can see on the slide, here are some common ones. Sigmoids that we have just dealt with now, and the last one, that is ReLU activation function or rectified linear unit. It is basically linear everywhere. Can you see the straight line? It's linear everywhere, right? Except there's a non-linearity at x equal to 0. So there's the, as you can, if you can observe, there's a step or a break or a discontinuity there at x equal to 0. So why do we use ReLU? It's very easy to compute. Still has a non-linearity and it's very fast in compared to sigmoid. Interesting, nice. So I guess all your does any of you have a doubt here? Okay, I think it was pretty clear enough. I'm going to continue the next slide. So why we need a non-linear function in the first place? We have to introduce a non-linearity. It's important because, you know, if you think of a real world data set, it's not going to be linear. It's just the way they are. As you can see, can you, as in the ML part, Baya taught you that you could use a best fit line to segregate all these points. Can you use a line here to segregate points? Like, it's a data set. I want to segregate the red dots and the green dots. Can I use a linear function to segregate this, guys? Please tell me a yes or a no. Would a linear function be efficient here? Yes. If you look at this data set, if I ask you to build a neural network that can separate these green and red points, this means we actually need a non-linear function. We cannot solve this with a single line or a linear function as an activation function. But adding non-linearity network to be smaller by allowing them to be more expressive and capture more complexities in the data set. So building a neural network. Now let's say we have a multi-output function. So you can see here, right? Yeah, I don't think so you guys have doubts. Yeah, so moving ahead. So we have a multi-output function that is 2 neurons. Can you see two, like the red ones? Those are neurons. Even the blue ones are the neurons. 2 neurons in the output, right? Every neuron sees the input that comes before it. But the top neuron is going to be predicting its own answer and the bottom will predict its own. They are independent since neuron has its own weights. Okay? So, moving ahead. Single layer neural network. We have one layer between the input layer and the output layer. So guys, I guess the name input layer and output layer is self-explanatory. Input layer is basically the first layer where the data is going to be fed in, and output layer is basically where you get the output. So I don't think so I need to explain that. So we are slowly and progressively increasing the complexity of our neural networks. So we can build up all these building blocks. The layer in the middle is called the hidden layer. You don't really, yeah, Anyone? No. Go back. Yes. So I was talking about the hidden layer. You don't really observe it or supervise it directly. It gives your, why do we use hidden layers? It gives your neural network more learning capacity. So more the hidden layers, more learning, more accuracy, better prediction. Okay. Now we have a transformation function from inputs to hidden layers, from hidden layers to outputs. We have a two-layered neural network which means we'll also have two weight matrices. Let's look at a single unit of the hidden layer, that is Z2. Can you see the red one? That is Z2. That is the second neuron in the first layer. Same perception as before. What we did, we compute its answer by taking a dot product of its weight. Right? Guys, react. And adding a bias term and then applying a non-linearity. If we took a different node like Z3, it's basically the same thing except the weights are different. So moving on to the next, what is a bias? So Raghav, bias is basically like, you remember the linear equation y equal to mx plus b? Bias is basically the intercept. So when don't we have a bias? When the line passes through 0, right? So what does the bias do here? It shifts the line horizontally on the y-axis so that the intercept value is not 0. Did you understand, Raghav? Okay. So moving on, applying neural networks. So now at least we have a solid foundation understanding how to define an entire neural network. So let's look at how we can apply these neural networks to solve a real life problem. So here's a problem on how we want an AI system to learn to answer the question, which will I pass my n terms or not? Isn't that a question that, can you explain about the bias again? Yes. So Jitesh, do you before you observe this equation, right? Y equal to mx plus c. So what is c there? C is an intercept. It's basically where it cuts your x-axis or y-axis, right? So when would c not be there? Y equal to mx. If you plot the graph, it's basically a straight line passing through the origin. So there we lack a 0. This usually doesn't give accuracy. So what we do is we add a bias term, an intercept, so that it shifts the line or like the non-linearity horizontally on the y-axis so that we get an intercept and that it's more accurate. Is it clear, Jitesh? One more yes. Okay, you're welcome. So we were discussing on the question, will I pass my end-term exams? Isn't that a question all of us are wondering now that our end-terms are progressively approaching us? Time is going super fast. So let's solve this real-life problem. So to do this, let's start with a simple input feature model that concerns ourselves. So what are the dependent things? Number one, how many classes you attend. Do you guys attend classes? That's an important factor, right? For whether you'll pass the exam or not. And the second factor is how many hours you spent on studying for the exam. So let's, next slide please. So let's look at some of the past data. This is the past data. We can actually observe how different people have lived in this space between how many classes and how much time they've spent on studying on their final exam. As you can see, every point is a person on the color. So next slide. And the purple dot there, that's you, okay? So we're going to predict whether you will pass or fail the exam. So observe, where are you near? You are near the green dots, the passing dots. You are away from the red dots, the failing dots. Okay, so you should actually pass the exam, but we'll see what our neural network is doing. So you have attended, this means you have attended 4 classes and you will spend 5 hours studying for your final exam. And you want to build a neural network to determine, given everyone else, what is your likelihood that you will pass or fail in your exam. So now we have all the building blocks to solve this problem using neural network. So we have 2 inputs, that is the number of classes you attend and the number of hours you spend on your final exam. It's 4 and 5 respectively. Please pay attention on the screen. We can pass those values, those 2 inputs, into our 2 variables x1 and x2. These are fed into a single hidden layer neural network. It has 3 hidden units in the middle. We can see that the final prediction output probability is 0.1, that is 10%. It's a very bleak outcome, right? Actually, if you look before, the probability should be 1. We would actually pass, but it's predicted, it's predicting that we are failing. But when we looked at ourselves on the plot, on the graph before, the purple dot, you are passing, right? Why is it telling that you're failing? So attending 4 classes and spending 5 hours, you would have actually passed looking into the feature space. So what has happened here? Why did it go so wrong? Because it's not trained. So this neural network is not trained. We have shown the red and green data. So we haven't learned anything. We haven't shown the red and green data to this neural network. So they haven't learned anything. So there's no expectation that we should keep on them to be able to solve these types of problems before we even teach them what the problem is, right? You just can't expect, I can't expect you to know DL before I teach you what is DL, right? It's randomized. Raghav, it is like the prediction, it will take some random values and it will predict. And because it's going wrong, we will train this network saying that it's wrong, go back and rectify until you give a right answer. Okay? So to train the neural network, we first need to tell our neural network when it's making a bad decision. So we need to teach it, train it, to learn exactly like how we as humans learn. For example, the actual value of you passing the exam was a probability of 100%, but it predicted a probability of 0.1. We compute what's called a loss. So the closer these 2 things are, the smaller your loss should be and the more accurate the model should be. So let's assume we have data not just from one student but from many. And now we can plug all these values into the neural network and show this to the system. Now we care not only about how the neural network did on just predict 1, but we care about how it predicted all of these different people that the neural network has shown in the past during the training and learning process. So when we train the neural network, we want to minimize the empirical loss between our predictions and the ground truth. We are going to do this on an average across all the inputs so that the model can be accurate. If we look at this problem of binary classification between yeses and nos, will I pass or not? For this, we can use softmax cross entropy function, which will be able to perform this on the network, giving a correct or incorrect answer. This function, think of it as an objective function. It tells our neural network how far away the probability distributions are so that the output is a probability distribution that we are trying to determine of how bad of a neural network is predicting so that we can give a feedback and better the answer. Next slide, please. Next slide. So the last topic here is backpropagation. It's Basically the same thing that I've kept telling over and over again, but like to just end it properly, I would tell you what backpropagation is. It is primarily used to train artificial neural networks, particularly feed-forward network. It works iteratively, minimizing the cost function by adjusting its weights and biases. So as you learned in the ML part, what's a cost function? It's basically the loss, the difference between the predicted and actual value. So in each epoch is like a cycle, okay? Like every time it goes, like completes one whole cycle, the model adapts these parameters that are the weights and biases, reducing the loss by following the error gradient. You learned what a gradient descent is, right? In the ML part. So backpropagation often utilizes optimization algorithms like gradient descent. The algorithm computes the gradient using chain rule from calculus. All of you know differentiation chain rule? It's basically what's used for backpropagation, allowing it to be more efficient to navigate complex layers in the neural network and to minimize the cost function. Okay guys, if you guys have any doubts so far, raise your hands, or if you've understood, just let me know with a yes and we'll continue on with the next topic. Okay, so the last topic is backpropagation. So what is backpropagation? As I told you, our neural networks, they just don't give you a proper output in the very beginning. They are trained over and over again until the accuracy is increased and the prediction value is right. So how do we do this? How do we train them over and over by minimizing the loss? This process is called backpropagation. So it is used in ANN, that what we've learned now. It works iteratively, that means cycle by cycle, minimizing the cost function by adjusting the weights and biases. Can you see the arrows there? Each arrow contains its own weight. So if the weight, say, let's suppose the weight is 2, and apparently the weight shouldn't have been 2. It should be lesser than 2. So what it does, it goes back, it reduces the weight, and then the cycle runs again and produces an output, and now the output is more accurate than before because we have edited our weights and biases using back propagation. Was that clear, Kritanu? Yeah, it's an algorithm. Did you understand the gist of it? It will be explained in the further bits. Okay. Yeah, we'll be explaining it ahead. Please be patient. So now I'll be handing over the next part to Sudeep to continue with CNN.
For it. That was amazing stuff. So I will be teaching you convolutional neural networks, or basically known as CNNs, which are used to it is a special kind of neural networks used for processing data that has known grid-like topology. And what is known grid-like topology? It's actually images. As you can see here, images. So you will ask me, how images have grid-like topology? What are images? Let me show you. An image is nothing but a collection of pixels arranged in 2D matrix, and each pixel has a value of in between 0 and 255. 0 means dark and 255 means bright. 255 represents the brightest it can be. So a grayscale image, but here in the image shown, we have actually given it a range of 0 and 1, where 0 represent dark and 1 represent, yes, anyone has raised a hand? Let me see. Okay, the range. Okay. I'm telling you. So here you can see what is an image. An image is a collection of pixels in a 2D like matrix set. As you can see, each box here represents a pixel. Here it is a pixel. Here it is a pixel. And pixel, as you can see, holds a value between 0 and 255, where 0 represents dark and 255 represents white. But here what we have actually done is 0 is remaining as 0 and 255 we have actually taken it between a range of 0 and 1. So you can assume that 255 is equal to 1 and 0 is equal to 0. So the range of 0 to 255 has been fitted in between the range of 0 and 1 here. But in real life, we never use grayscale images. You have seen very much less black and white images right now. We mostly see colored images. So what are colored images? Colored images are nothing else but the same thing. But here we have 3 channels. We have the same 2D matrix but in 3 channels. The first, like each channel contains a color, or as we know it, primary colors, red, green and blue. So each of these overlap to form a colored image. So this is actually a representation of a colored image. As you can see, each colored image has 3 channels consisting of primary colors, red, green and blue, which overlap to form the image. And each of these 2D matrices has value between 0 and 255 in each of their pixels. So these are called images. Okay. Any doubts in images? Please raise your hand or you can type in chat. Yeah, like in yeah, we can actually train any model to do sorting for ourselves, but actually that is different. We have to, in data structures, we have to like explicitly program the model to actually sort anything. But in ML model, we can give it pre-sorted data and data that have been not been sorted to and data that have been sorted. So it can actually learn from it and sort the other unseen data by its own. So it's similar but not, their उनका function same नहीं है, वो similar है लेकिन function same नहीं है. So any other doubts, please raise your hand or you can type in chat. Yeah, so no doubts are coming, so we can go on. So what is CNN? As you can see, CNN is nothing but a neural networks and it consists of 3 layers. A convolution layer, and hidden between each convolution layer there is a pooling layer here, and a fully collected layer which you have already been taught, that is also called ANN. These consists of perceptrons or neurons that you have already learned before by Lakshanya has taught you. These are called perceptrons or neurons. And you must be wondering what are convolution layer, what are pooling layer. You haven't learned any of this. Don't worry, I will teach you going ahead. So the first CNN structure was built actually by Jan LeCun in 1998. So it is a very recent discovery, as you can see. It was for scanning bank checks automatically and it was called LINET5. It actually recognizes a handwritten character which I will show you all. Okay. So how to identify any image? हम एक इमेज को रिकॉग्नाइज कैसे करेंगे? ये 9 है, हम कैसे जानते हैं कि ये इमेज 9 है? तो पहला हम देखते हैं इसका कुछ फीचर्स और उनको हम बोलते हैं एजेस. ये है एक एज जो हम यहाँ पे दिखाया है, ये है एक एज जो हम यहाँ पे दिखाया है, ऐसे ही ये है एक एज जो हम यहाँ पे दिखाया है, ये है एक एज जो हम यहाँ पे दिखाया है, नहीं यहाँ पे दिखाया है, और ये है एक एज जो हम यहाँ पे दिखाया है, और ये एज सब मिलके they form a more bigger feature here, here, and at last they whole combine to form the image 9. Okay, so this is how we identify an image. First we extract its feature or called as edges. So someone has raised a hand. Okay,
You can just type in the chat, okay, Dipendu. Dipendu, you can type in the chat your doubt, okay? Okay, you're not giving any doubts, so I will move on, but you can type in chat and I will solve it later on, okay? So, how do we extract a feature from an image or an edge from an image? We actually use what are called as filters. This here is a filter. And you also be wondering what is a filter. I'll teach you later on, don't worry. We use filters to extract a feature from an image and feed it to the neural network. The first layer actually extracts very primitive features. Like this is a small edge that is extracted from here. This is a small edge that is extracted from here. These are all primitive features. The second layer actually gives us more complex features. You can see here is a complex feature, this is a complex feature, this is a complex feature, and in the next layer this is half of the image. This is half of the image, and the last layer is whole the image. So all this layer combines to form the image at last. And the first layers actually extract very primitive features, and the last layer we get the image. And we use the convolving operator to do this. I will be teaching it to you next, don't worry. So why don't you use ANN for image like classification? Why do you use CNN? See, if you want to use ANN, it will take very high computational cost. See, this is a 28 cross 28 picture, and if we unpack this 2D image into a 1D grid and feed it to an NN, the number of weights and biases, as we have read by Lakshanya has told you, weights and biases, each of them have considerable, there are considerable number of them according to the inputs and the number of perceptrons. These are also called trainable parameters because weights and biases are not known before to us. They are actually trained by the model, okay? They are decided by the model itself. So these trainable parameters would be so high that the computation required to determine their optimum value would be astronomical. Even the modern range GPUs take very much amount of time to train these models. So it would be very time consuming. Next, the problem of overfitting. As you have been already taught by Rishi, overfitting means that actually it performs well on our test data. On our trained data, it performs very well. But in unseen situations, it does not perform up to par. Like it adapts itself to the test data only. It doesn't actually perform very well over the unseen data. And loss of important information like spatial arrangement of pixels. The distance between eyes and nose of the monkey is very important feature. Like this, you can see the distance between the eyes and the nose of the monkey is a very important feature. Here the eyes is in relative position to this eye and this eye is in relative position to this nose. This is actually a very important feature. But in NN, this spatial distance is not taken into consideration. There are two eyes and one nose. That is only taken into consideration. Not the distance between the two eyes and not the distance between the eyes and the nose. So ANN can be used to like perfectly perform classification models in images. Okay. So any doubts regarding this? So why can't we use NN to perform classification in images? Please give a raise of hand or you can type in chat. Are these basic features also fed to the machine as training data? Yeah, Rupdeep, yeah. These features are fed to the machine as training data only. Any other doubts? Yeah, so moving on. what are the applications of CNN? As you can see here, the first application is image classification. Here we classify this SIP. As you can see in this image, there is a SIP. The percentage of this SIP being a container SIP is very high, and the percentage of this SIP being a live boat is very low. So this model accurately classifies this SIP as container SIP. Same with object localization. We can find the height and width of any object with this. It also creates a bounding box between the objects, like we can track the object going anywhere in our frame. Object detection. This detects the object, like this is a human standing here. You can see these numbers represent actually accuracy of this prediction, like 69%. This model is 69% sure that this is a human standing here. This is a bicycle, 80% sure that this is a bicycle. This model is actually predicting the values. This is a bus, 98% sure, the model is 98% sure that this is a bus. It's called object detection. And facial recognition. You can see here, these are actually edges. These are edges of your faces that the model predicts to form the whole image of your face. You can actually we use this in like our everyday life. In facial recognition, you may have in your phone. Then image segmentation. We can see that this part here is preserved for the river. This part here is preserved for the grass, and this part here is preserved for the tiger. We can divide the object into different segments. Resolution scaling, like we can upscale low resolution image to high resolution image. Then black and white to color images. We can actually convert black and white images to color images using this CNN. Posture estimation. This is actually very useful in gaming industries where like the real life motion of human is converted into the motion of the like playable characters in the games. This is actually done with posture estimation using CNN. So next, this is actually the most important part. So this is the convolution operation. As you can see, the name of our topic is convolutional neural networks. So the convolution operation is the most important part in this topic. Okay, so please pay attention to this. This is the most important part you have to know. So how do we, as I have told you, to identify any image, we have to extract the features and feed it to the machine. Or we also call this feature as edge detection. So we have to basically do edge detection on any image first. What are edges, you may ask? Edges are basically the changes in intensity in the image. Here you can see an image of a backside of a van. So first we have to like extract the vertical edges. So we do this here. Like this is a vertical edge. 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 Okay. And this is a horizontal edge. 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 So this is done using the convolution operation. How this works, I will show it to you right now. Let's assume that this is a 2D matrix that represents an image. How will this image look like? It will look like this. The upper side will be blank and the lower side will be dark. How this convolution operation actually works is that we take this filter. This is a filter. What is a filter? The filter is also a 2D matrix that has some random numbers in between them. The numbers are actually determined by the CNN model using back propagation. You don't have to give these numbers to the model. These numbers are actually determined by back propagation. So I actually know this filter is actually for horizontal edge detection. So I know this, so that's why I use this as an example. So how will this work? We'll take this matrix and impose it on this matrix, our image matrix. So this will come here, first 3 layers, and we'll multiply each box with each box of this. This will be multiplied with this will be multiplied with this, and this will be multiplied with this, and so on. So first we'll get a result that is actually equal to 0 here. So this will be our result of the first box of our resultant matrix. same case here, we'll do this again here, and we'll go actually, let me change the color for you to visualize this properly. See, we'll do this next, but we'll move on one step to the side. This is actually called a step, or we also call this a stride. Okay, I'll teach it to you later on. And same thing we'll do again. We'll also get a resultant 0 here. Next thing, we'll also move it again to the side here, and we'll also get a resultant 0 here. Next, we'll again move it to the side, and we'll also get a resultant 0 here. Same, we can then afterwards, sideways is all over, then we can come down one step. We'll come here one step. And then again we'll perform the same operation. We'll also get 0 here, 0 here, 0 here, 0 here. But after this we'll get 1 here, 1 here, 1 here, 1 here. And 0 here, 0 here, 0 here, 0 here. So our resultant image will be like this. And a line in between. This is our resultant image, which is the edge between, which detects the edge between this image. Like this, up is dark, down is white. So the edge will be this. This is our edge. So this is how we detect edges using convolution operation. As you can see here, the filter is a 3x3 matrix, and the star sign is actually called the sign of convolution operation. Okay. So when we perform this operation, you may be asking that this is getting multiplied by 255. So how are you getting this 1 here? Actually, we actually perform the activation function ReLU on this. ReLU, as you have been taught by Lakshanya, is just like we do negative numbers, that are all negative numbers are converted to 0, and all positive numbers remain as themselves. So here the negative numbers don't actually affect anything, they all get converted to 0. So just like weights in ANN, which do not need to be decided by us, the filters, the value of these filters in CNN are also not needed to be determined by us. They are determined by the CNN model itself using backpropagation. I actually want to show you a demo of convolution operation, how it works. Okay, so let's see this. You can also do this yourself. Go to the deeplira.com and type convolution operation. You can see this yourself. So any questions up to this part, please? Please repeat how we do the operation between the matrix. Okay. Raghav, I will repeat it again for you. Let me raise this. These are gotten. Okay. So see, this is a filter. Okay, a filter that is a 2D matrix, and we have taken 3x3 matrix here, but we can take anything. The filters, the value in between the filters are not needed to be determined by us. They are determined by the CNN model itself using backpropagation. And the convolution, you have doubt in convolution operation. No, I'll show it to you. The first we need to take this matrix and put it on this matrix. This is an image. This is our image. We need to put it on this matrix. Okay, like this. This matrix has come here, and we multiply each box with the position. This is a 1. Let's assume this is 1,1. So we multiply the 1,1 of this matrix with 1,1 of this matrix, like -1 into 0. Okay. Then again we multiply this position 1,2 with 1,2 here, -1 of this position, and 0, 1,3 with 1,3 of this position. We'll do this for the whole matrix, and we'll sum all of this to get an answer. Here in this case the answer will be 0. So that will be the resultant for our first box of the resultant matrix. Okay. Similarly, then we'll go one step to the side and perform it again. We'll again go one step to the side and perform it again. We'll go another step to the right and perform it again. We'll get 0 for all of this. I know the answer beforehand, so you don't have to worry. and then again we'll come down one step and perform this operation again. We'll come to the side and perform this operation again. Again we'll come to the side and perform this operation again, and again this will come to the right and perform this operation again. So we'll get some resultants here. Similarly, we'll come down again, then we'll do again. We'll get some operation resultants here, then we'll come down again and perform the same operations again, then we'll get another operation here. Then we get this whole resultant matrix that we call a feature map. And we apply the value operation on it to make the values between 1 and 0. Okay. Raghav, you understood now? What is padding? As you can see here, this is actually an image. This is an image, and there is a layer of 0 upon it. This layer of zeros is actually called a padding. And why do we need padding? See here, as you have seen before in convolution operation, the size of the image was actually 6 cross 6, but the feature map we got was actually 4 cross 4. So every feature map is actually getting decreased in size. So there is information loss. So how do we accommodate this information loss? We just provide a layer of padding upon it, a layer of zeros. Then we get the feature map that we have shown here. Then we get the feature map that is shown here as a 5 cross 5, which is the original size of the image. So there is no information loss here, and the feature map is the size of the image. See, in the example above, the 5 cross 5 image is padded to 7 cross 7 by adding a layer of single pixel row columns. These are single pixel row columns with each a value of 0. So I will want you to ask you a question. How are the size of the image and the size of the feature map related? You can see here, without padding, the size of the feature map that comes out is actually n minus the size of the feature map plus 1. This is the formula for the size of the feature map. Okay. So in the previous example, the 6 cross 6 image will give a feature map of 4 cross 4. How do we determine that? 6 minus 4 plus 6 minus 3 plus 1. 3 is the size of the filter. Here you can see the size of the filter is 3 cross 3. So 6 minus 3 plus 1, which is equal to 4. This is the size of the feature map we get here, 4 cross 4. So how does padding affect the size of the feature map? You can see the formula becomes n plus 2p minus f plus 1. N here is, if we take the previous example, n here was 6, and if we provide one layer of padding, that is 2, and the filter size is 3 plus 1, which will come out as 6. So the size of the image and the size of the feature map remains same. You may ask, should we always take one layer of padding? As you have seen, it is sufficient to retain the size of the image in all the convolution operation we have done till now. The answer is no. As the stride we have taken as 1 in each of the convolution operation. What was stride? I have told you what was stride. Here stride is actually this. First you convolute this matrix on this, then we go one step to the side. This one step is called as stride, and we have taken here stride equal to 1. That means we take one step to the right, and same as one step to the down. Okay. So as you know, we can increase the stride, like we can take 2 steps to the side after the first convolution operation. this is the first convolution operation. Right, let me change the color. This is the first convolution operation that we do here. And after that, we can take 2 steps to the side, and this is the second convolution operation we can do here. So here stride will be equal to 2. But the problem becomes that there is very much information loss as the size of the feature map decreases to a very minimal amount. As you can see here, how size of the feature map is connected to the strides. The formula is divided by strides. So you can understand from this only that increasing the strides result in very much decreasing the size of feature map. So very much amount of information is lost. Okay. If the image is taken as 7x6, this is a 7x6 image, and a filter of 3x3 is used to get the feature map, what would be its size? Can you tell the answer? Any answer please in the chat? See, the image size is 7x6 and the filter size is 3x3. So what will be the size of the feature map? I have given you the formulas, okay? You can just calculate and give the answer in the chat.
5x6.
Again, please, can you say it again? You couldn't catch that.
5x6.
Okay. 5x6. And that's actually correct answer. Without padding, this is actually the correct answer. So that's why I showed you the answer so you can get it wrong, okay? That was a trick question, you got it right. Here I have written 3x2 because the stride is actually taken as 2 here. Okay, you understood? Good answer. Raghav, I think gave that answer. Good answer, Raghav. So, in the formula, if we get decimal, like if we are dividing by strides and we get decimal somewhere like 3 by 2 becomes 1.5. So what will the 0.5 indicate? We just floor the 0.5, like we make it 0 and we take 1 as our value, okay? Like when we get feature maps. Please keep that in mind. That's actually a very important thing. So you may have a question. If there is only information loss and only negative effect of increasing the strides, then the question rises that why do we need strides to be greater than 1? Why do we even need strides to be greater? Okay, so here is the answer. Only when high level features are required. When you don't need to take into account every little tiny detail and only require high level features. Like in this thing, we only require the monkey here. Okay. We don't require the white spaces and all these that are here to train our model actually. We don't need all these features. We only need the features of the monkey. So these are all irrelevant details. So when we increase the stride to 2, actually the unimportant features gets discarded. Only the high level features are taken into account. Next, the computing power. As training takes a lot of time with a large data set, even with a higher end GPUs. Nowadays everybody must have a GPU in their laptop or anything, but with the help of GPU even, it takes a lot of time to train any CNN model. Okay, so computing power is a very important thing. So with a large data set, the overall info from the data set can be reduced using strides to lessen the training time. Usually in strides we take it as 1 while training any model, but if you have any constraints in your time or in GPU, you can take the strides as 2. So are there any doubts regarding this topic? If not, please give me a thumbs up so I can move on to the next topic. Can you show the formula of size once more and explain the terms in the same again? Okay. Thank you. I'll be showing it to you here. So here, this is the formula of the feature map that we get after doing the convolution operation, which is n minus f plus 1. N is the size of the image we are taking. in this example, the size of the image will be 7 cross 7. Okay, 7 will be the size of the image. The size of the filter here is 3 cross 3. So F will be 3 here and plus 1, which will be equal to 5. That is the size of our feature map. You can see the size of our feature map is 5 cross 5, which was the size of our original image discarding the padding, because padding is only adding a layer of zeros over your image. It is not needed. So the original size of the image was 5 cross 5. The original size of the feature map comes out to be 5 cross 5 too. Understood? Next, the second formula in which we use padding, we just add plus 2p term to that same formula, where p is equal to number of padding layers. Number of padding layers means here there is one padding layer over the image. So the number of padding layer here will be 1. Okay. Number of padding layer here is 1. Understood? Any other doubts? Anyone else? Any other doubts? If not, please give a thumbs up so I can move. Yes, Himanshu, raise your hand. You can type in the chat, okay? Okay. Overwhelming thumbs ups. Okay, so I have to move on. No doubts, so we'll move on. So coming to the next topic, pooling operation. I have told you before that there is a pooling layer in between the convolution layer. Here you see there is a pooling layer here in between the convolution layer. This was a pooling layer just hidden before. I will show it to you what actually is pooling. So before going to pooling, as we have seen, convolution operation can extract features and feed it to the machine. So why do you even need pooling? So let's see. First issue is the memory issue. What's the memory issue, you may ask? Let's see here. Let's take a 228 cross 228 cross 3. 3 is the number of channels in an RGB image, as I've told you before. And let's take a 103 cross 3 filters. As you know, I've told you what filters are, but mostly we do not take filters as one. We take many filters as one, many filters at the same time to get the get features from real life images. Then the size of the feature map will come out to be 226 cross 226 cross 100. As you know, how this 100 comes out to be. So each filter gives us one feature map. Okay. So 100 features will give us 100 feature map which overlap on each other. Okay. So 100 feature map for each filter. So the entire thing will take somewhere around 19 GB in your RAM. Okay. But that only for one image. Usually we give images in batches of hundreds or even thousands. And that would take GBs of your RAM, which would result in your system slowing down. And don't even talk to me about training the thing. Okay. It will take very much time. Then the second issue comes the translation variance. What is translation variance? ये image देखो, यहाँ पे एक बिल्ली है. ये बिल्ली लेफ्ट को हो या फिर राइट को हो. यहाँ पे बिल्ली लेफ्ट को है, यहाँ पे बिल्ली राइट को है. बट वो कोई फर्क नहीं पड़ता. वो कुछ फर्क नहीं पड़ता क्योंकि ये बिल्ली इमेज में तो बिल्ली ही है ना, लेफ्ट को हो राइट को हो. बट in convolution operation, the feature extracted become dependent largely on the location of the feature. मतलब यहाँ से तुम बिल्ली का कान का फीचर लाए हो, तो यहीं पे बिल्ली का कान जो फीचर है ना, वो बहुत डिपेंड कर जाता है जब कॉन्वोल्यूशन ऑपरेशन होता है. ये जब बिल्ली इधर आता है और इसका कान इधर हो जाता है, तो वो हमारा मॉडल को आइडेंटिफाई नहीं कर पाता है. This thing is actually called translation variance, and we can't solve the problems using this problem using strides. Okay. So we add the pooling layer after doing the convolution operation and after applying the ReLU function. ReLU function में तुमको बताया था कि 0 और 1 हो जाता है, मतलब जो नेगेटिव वैल्यू होता है उसको हम फ्लोर करके 0 बना देते हैं और जो पॉजिटिव वैल्यूज रहता है वो ऐसे ही रहता है. So pooling का बहुत टाइप्स होता है, min pooling, max pooling, average pooling, global pooling, बट हम मैक्सिमम टाइम मैक्स pooling ही यूज करते हैं क्योंकि वो सबसे इफेक्टिव चीज होता है. So चलिए अब समझते हैं मैक्स पूलिंग क्या होता है. ये देख सकते हैं, दिस इज अ 4x4 image or matrix you can say, and we give the stride as 2x2, like we take 2x2 matrix in this is a 2x2 matrix, 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 and in each of this matrix we find the maximum value. What is the maximum value in this matrix? It's actually 5. What's the maximum value in this matrix? It's actually 3. What's the maximum value in this matrix? It's actually 7. What's the maximum value in this matrix? It's actually 4. So our resultant comes out to be 5, 3, 7, 4 in a 2x2 matrix. This is what happens in max pooling. Max pooling this happens because we have taken the size as 2x2 and stride as 2. So we take this first 2x2 matrix, then we go 2 steps to the right, then we take the second 2x2 matrix, then we take 2 steps down, we take the second 2x2 matrix, then we take 2 steps to the right and take this 2x2 matrix. And in each of these areas we find the maximum value, which is 5, 3, 7 and 4, and we provide them in a 2x2 matrix. This is actually what a pooling does. So I will ask you another question. Let's do it here. Here. So if we have a 28 cross 28 image and we have to do pooling on this. Okay, we have to do pooling on this. What will be the size of the feature map extracted? Can anybody answer in the chat, please? Anyone? Try to answer, okay? We take strides as 2x2, okay? So you don't have to worry about being wrong. You can just answer. Okay, we have got the answer 7x7. Any other answers? 14x14. Yes, Jitesh. That's actually the correct answer. The answer is actually 14x14. Very good to Dipesh and Raghav too. Yeah, you two have given the correct answer. So the answer will be actually 14x14. If we take size as 2x2 and strides as 2, our image just gets cut in half. As you can see here, the 4x4 matrix gets reduced to 2x2 matrix. We take all the dominant features in a small receptive field. So you can consider this as a small receptive field, and we took the most dominant feature, that is 5, from this receptive field and put this in our feature map. You can see here, and discard all others which can be said as low level details, and discard all other low level details. These are all low level details that we discard. So this is a type of translation invariance while downsizing the sample. So we actually solved both of our problems with pooling. हम इमेज को छोटा भी कर दिए और उसका जो ट्रांसलेशन इनवेरिएंस होता था, मतलब ये छोटा एरिया में सबसे डोमिनेटिव फीचर उसको भी ले दिए, तो दोनों प्रॉब्लम हमारा पूलिंग सॉल्व करता है. और मैं फिर से तुमको एक दिखाना चाहूंगा, मेरे पास एक पूलिंग का भी डेमो है. सो जस्ट वेट अ मिनट. Okay, so let's go step 1, step 2, step 3, step 4, and we go on. Here you can see the values are starting to come. So I'll just play it out. See, the most dominant features get there, and एंड ऑल द नॉन डोमिनेंट फीचर्स, लाइक इतना सारा नॉन डोमिनेंट जीरोस था यहाँ पे जो कुछ काम का नहीं था, तो उसको हम डिस्कार्ड कर दिए और सारा डोमिनेंट फीचर्स यहाँ पे आ गया. तो मैक्स पूलिंग यही करता है. ये मैक्स पूलिंग का डेमो था. फिर से तुम लोग deepleaser.com में जाके देख सकते हो मैक्स पूलिंग का डेमो, तुम अच्छे समझोगे पूरा वहां पे. मैं यहाँ पे दिखा तो दिया हूँ. सो मूविंग ऑन. कोई डाउट है पूलिंग में? सो कैन आस्क एनी क्वेश्चंस यू हैव. Okay, so I don't see any questions coming this way. Okay, so we can move on. So advantages of pooling. What are the advantages of pooling? Reduce sample sizes, as I have shown you. The 4x4 image gets converted into 2x2 feature map. Translation invariance, यहाँ पे ये देखो, ये तुम अच्छे समझोगे. ये 8 लेफ्ट को है और ये 8 राइट को है थोड़ा, बट दोनों जब हम पूलिंग में डालते हैं दोनों का रिजल्ट सेम आता है. As you can see, both have the same feature map. So this is a type of translation invariance. मतलब ये 8 कहाँ पे है फर्क नहीं पड़ता, ये 8 ही है. In our image we have 8, but image का पोजीशन तो डिपेंड नहीं हो रहा है. And enhance feature, only in case of max pooling we can enhance our feature actually. So ये देखो, ये एक इमेज है, इसको मैक्स पूलिंग में जब हम डाले हैं तो इसका फीचर सब एनहांस हो गया है. As you can see here, the features are enhanced. And the most important actually this is, we actually don't need to train anything in pooling. This is just a mathematical functions that is actually matrix multiplication that works. We don't have any trainable parameters here. So मतलब जब हम इसको ट्रेनिंग में डालते हैं तो ये कुछ कंप्यूटेशनल स्पेस नहीं खाता है, बहुत इजीली ये मैथमेटिकल अपना काम करके चला जाता है, कुछ ट्रेन वगैरह नहीं करना पड़ता है. जैसे कि कॉन्वोल्यूशन लेयर में हमको फिल्टर्स का वैल्यू जानना होता है ट्रेनिंग करके, जो मतलब CNN मॉडल खुद से देता है. बट इन पूलिंग वी डोंट हैव टू फाइंड एनी वैल्यू. CNN मॉडल डजंट हैव टू फाइंड एनी वैल्यू, इट जस्ट हैज टू परफॉर्म द मैथमेटिकल ऑपरेशन एंड मूव ऑन. But there are some disadvantages to pooling. There are some cases where translation variance is required. Like in case of self-driving vehicles. अगर तुम्हारे आगे ह्यूमन चल रहा है तो ये ह्यूमन कहाँ चल रहा है तुमको भी पता होना चाहिए ना, कि तुम उसको अवॉइड कर सको. तो यहाँ पे ट्रांसलेशन वेरिएंस का जरूरत होता है. ट्रांसलेशन इनवेरिएंस यहाँ पे इनवैलिड होता है. एंड इमेज सेगमेंटेशन, एंड इट इज वेरी गुड, बट दिस इज वेरी गुड फॉर क्लासिफिकेशन. लाइक कुत्ता यहाँ पे हो, कुत्ता यहाँ पे हो, दोनों जगह ये कुत्ता ही होता है. लाइक लेफ्ट को राइट को मिडिल में हो, कोई फर्क नहीं पड़ता. एंड द मोस्ट इंपोर्टेंट disadvantage is a loss of lot of information, like a 4x4 matrix become a 2x2 matrix. The feature map get reduced by 75%. We lose 75% of the features. So there is a 75% loss of information, as you can see here. Lot of information is lost. So any doubts? One example repeat. कौन सा example repeat करूँ? फिर से थोड़ा specify करूँ. समझ नहीं पाया कौन सा example repeat करना है तुमको. Deep चैट करो. अच्छा 8 वाला एग्जांपल. ओके ओके. एज यू कैन सी हियर, ये जो 8 है, दिस 8 इज अ लिटिल बिट टू द लेफ्ट एंड दिस 8 इज अ लिटिल बिट टू द राइट. तुम्हें अगर मशीन को बोलना है कि पहचानो ये 8 है कि नहीं, तो ये लेफ्ट में हो या राइट में हो कोई फर्क पड़ता है? ये 8 ही तो है ना. दिस नंबर इज 8 इवन इफ इट इज टू द लेफ्ट, इवन इफ इट इज टू द राइट. तो जो फीचर मैप तुमको चाहिए वो इसका और इसका अगर डिफरेंट मिलता है तो थोड़ा प्रॉब्लम होगा. तो हम क्या करते हैं, मैक्स पूलिंग निकाल के तो दोनों का फीचर मैप एक ही आ जाता है. इसको हम बोलते हैं ट्रांसलेशन इनवेरिएंस. दोनों का फीचर मैप एक ही आता है. ये 8 साइड को हो, इस साइड को हो या फिर इस साइड को हो, कोई फर्क नहीं पड़ता, ये 8 ही है. Got it, Deep? Do I need to repeat again? Any more questions, doubts? You can just chat. Okay, okay. So you got it. So I'm moving on. Next is the flatten layer. As you can see here. After we get our feature map here, these are all feature maps corresponding to the filters. We flatten the feature map into a 1D array so that we can feed it to the neural network here, present here. You can see we have a 1D array and we are feeding it to the neural networks. Because neural networks cannot take 2D data. Neural networks have to take 1D data, so we have to flatten this to form a 1D grid. So flatten is used to transform multi-dimensional output of convolutional pooling layers into 1D vectors. So moving on to the next topic. What is the architecture of a basic CNN? So you can see this. Let's take this as an image, and let's take this as a first convolution layer. In between there is present a filter, and this filter we perform convolution to get this first convolution layer. And after this convolution layer, we perform a pooling operation. This is the pooled layer. And after this, we perform another convolution operation using another filter here. This is another convolution layer. After this, we perform another pooling, and after this, we get our last feature map, which is a collection of all the high level and important features here. And this is actually flattened, like formed into a 1D array and fed to the neural networks here. This is the basic architecture of CNN. People change this architecture here and there and build their own models. Like number of convolution layers you can change, number of pooling layers you can change, the size and number of filters you can change, number of nodes in the ANN layer you can change, and number of fully connected layers you can also change. There are 2 fully connected layers here. We can also provide another one here. People make their own architecture by differing only these characters. You can see in 3D here. This is an image. This is the first convolution layer. This is the second convolution layer. After this, third, fourth, and this is the fully connected layer. First, this is an image that we give. These are the basic primitive features that we extract. The more complex features that we extract, like eyes and nose. Then we have here the completed feature maps, which are like most of the faces you can see here. So let's show a famous architecture, that is the LINET 5 architecture, which was actually the first made CNN architecture, as I have shown you here. The LINET 5 was actually the first made CNN architecture that acts as handwritten character recognition. It consists of, first we feed it a 28 cross 28 image. Then we provided 6 filters, and we have provided the padding in the first layer. So the feature map is 28 cross 28 and the size isn't getting reduced. So we give 6 filters here. So we get 6 28 cross 28 feature map. Then we perform a pooling operation where we get 6 14 cross 14 feature map. Then we provide 16 filters. Then we get 10 cross 10 feature map. And how this 14 cross 14 is converting into 10 cross 10, can anyone tell me? How a 14 cross 14 feature map is getting converted into a 10 cross 10 feature map using convolution operation. So what would be the size of the filter here? Can anyone tell me? Using the formulas I have provided. How a 14 cross 14 can be converted into a 10 cross 10. So the size of filter should be what? Yes guys, any answers? Okay, I can see no answers. Okay, so actually, okay, yeah, Abhik, That's a correct answer. The size of the feature map should be 5. As you can see, 14 minus 5 plus 1, that is r equal to 10. So 14 is the size of the image, 5 is the size of the filter, plus 1 equal to size of the feature map. Avik, that was a very great answer. Next we'll perform the pooling operation again. Then we get 16 5 cross 5 feature map. Then we flatten this whole thing. 16 into 5 cross 5. So the answer will be 16 into 10, 160. 16 into 25, sorry, that's my mistake. And this is actually the number of boxes here that will be fed into this fully connected layer. There are 2 layers of fully connected and 3 layers of fully connected layers. First contains 120 perceptrons, or you call it as neurons. Second contains 84 and third contains 10. So this was actually a model built for handwritten digit recognition, used for bank checks, for recognizing bank checks automatically. Okay. So any doubts in regarding this? Please type in the chat or you can just react. Okay, so I see no doubts. So I'll be moving on. So the difference between ANN and CNN. The architectures of ANN is only consisting of fully connected layers. The architecture of CNN is actually convolution layers, pooling layers plus fully connected layers. As I've already told you before. The input type is 1D arrays, we give it in ANN, non-spatial data. In CNN, we give spatial data such as images and videos. A feature extraction. We in ANN requires manual feature extraction, but CNN automatically extracts the feature with help of convolution filters, and the values of the filters we don't have to give. The CNN model itself gives the value to the features using back propagation. Spatial awareness. ANN has spatial awareness. CNN doesn't have any spatial. Sorry, ANN doesn't have any spatial awareness, and CNN has spatial awareness. Application. General purpose task. This ANN is very good, but CNN is actually very good with image and video processing and time series data. Parameter sharing. No parameter sharing is done here. Uses parameter sharing and fewer parameters. Like in convolution neural networks, the weights and biases do not depend on the size of the input. Yes, any questions? I can see no questions right now. So moving on. So here, weights and biases actually do not depend upon the size of the input. Where can I show you an example? Like in here, CNN architecture. Here you can see the size of the image is 28 cross 28, and the size of the feature map is 5 cross 5. So what are the trainable parameters that we need here? These are actually the values of the matrix in the 5 cross 5 filter. Anything else is given to us already. So the only values we have to find are this, the size of the values in the 5 cross 5 filters. So even if we give it a 1080p image cross 1080p image, the number of trainable parameters remains the same. So the number of trainable parameters does not actually depend upon the size of the image. It depends upon the filter you are using and the number of pooling layers and the number of fully connected layers only, not the size of the image. Okay. So here you can see learnable parameters depend on the size of the filter rather than the size of the image. Therefore, CNN has less trainable parameters than ANN. And you know, there is no pooling in ANN, and pooling is only there in CNN to reduce dimensionality and competition. Like it reduces a lot of competition using CNN. So any doubts regarding this whole topic? In any part of CNN you couldn't understand anything, you can ask a question. Like not only in CNN versus ANN or pooling, anything. Okay, those who don't have a doubt, please give a thumbs up. Yeah. Good. Overwhelming responses. You all have understood, I think. So actually the next part is teaching you a Python. That is actually required to build any model in ML. You have to actually learn Python. That is a tool or the basic tool we use to build any model. So for this next part, I would like to invite Kashish to start off with the basics of Python. So thank you everyone.
Thank you, Sudeep. So guys, firstly, to apply any machine learning theory, Python is one of the easiest language to use. So let's dive into learning it. Before that, I hope you guys have joined the workshop with your laptop. If not, please take your laptop with your side, because whatever we are going to study, you can practice side by side. Let me just share my screen. Yeah. Okay. I think my screen is visible to you all. Guys, please respond. You can give a thumbs up. Okay, great. So firstly I'll tell you how you can I am using a Google Colab. Okay, you can practice in Google Colab also, but if you have any problem with that, you can also use any online compiler, Python compiler, and practice over there also. We are not going to do any merge programs, but a simple examples. Okay. So let me tell you how you can open the Google Colab. Just a second. First notebook. Okay. So a notebook will be shared to you where you can just run your program. Yeah, I got that. I hope you all can see this. I cannot see what you guys are saying, but I just expect that you guys will do with me only. Okay, just go with the flow with me. If I practice something, you can also do that. So I'll be teaching you guys very basic Python concepts, which will be including variables, comments, data types, and input outputs. Okay. So let's start and write our first program. As Sudeep asked you guys in the very first starting, that how many of you have learned Python earlier? And many people were like, yeah, they have already done. So you guys know, for writing programming Python, you don't need to understand that much things. Just a second. Major of you guys already have studied Python, so you guys know you don't need so much of complex knowledge to write any program in Python. Okay, so if very first thing, if you want to print something on the screen, you can just simply use the print function for printing it. Okay, so the first program we have written is like print, and the syntax, I'm just explaining you the syntax for the print function. It's like print, then the parenthesis, and inside the quotation you will write whatever you want to print on the screen. As we have written, welcome to the ML workshop by SAE. As you guys have already been welcomed, but still, once again, welcome to the ML workshop by SAE. And just let's run this, and yeah, we get the output as welcome to ML workshop by SAE. So this was the very first program and very basic program. In any programming language you will study, you will firstly, your first program you will write is something like that only, printing and getting the output. So let's go for the next topic, that is variables. Okay. As per the definition, variable is a name given to a memory location in a program. So variable is nothing but just a container inside which you can store some data and use in the program further. Okay. And you just give a name to that container. That's what we call a variable name. So the variable syntax would be like variable name equals to variable value. Let's for an example, we are writing a equals to 6. A equals to 6. Okay. So here 6 is the variable value which we want to store in the variable a. Okay. And we run it. It's getting executed. Yeah, done. So if you want to see if it's really working or not, you can just check and write print a. So it will be like, okay, and let's run this. It will be showing the result, whatever the value is getting stored inside a. Okay, so result is like 6. 6 is getting stored in a. So for variable, let's see an example of swapping two numbers. Okay, this is a question which you guys will see in any programming language. This is the most basic and most asked question of swapping of two numbers. So by just knowing how we can assign value in a variable to a variable, you can do this program. In this, what we are doing, we are just assigning a value of 5 to x and 7 to y. Okay, and we are just printing whatever we have stored to see that yeah, it is getting stored or not. The main part of this code is this line. Okay, in this line, what is happening? What is written first? See, x comma y is equals to y comma x. The concept before this is like the value which is stored in y gets stored in x, and the value stored in x gets stored in y. And here, this is the only line where the swapping is done. In other languages, and there are many other ways also, you can also take any third variable and do the swapping. But this is the benefit of Python. Studying Python, you can do it just in a one line. And after swapping, you can just print whatever the value has swapped. Let's see if the swapping is happening or not. Yeah, let's see. So before swapping, our value we assigned that 5 to x and 7 to y. And after swapping, the value got swapped, and the 7 is in x and 5 is in y. Okay. So I don't think there is any problem with this. So we will be saying the rules for naming a variable. For naming a variable in Python, there are certain rules which you guys need to follow up. Okay. I'll be reading the points. If you guys have any problem, please feel free to ask. A Python variable name must start with a letter or an underscore character. This is a simple English. I guess it's understood only. A Python variable name cannot start with a number. This point is related to the first point, that the starting of the variable name should only contain either an underscore or a letter. It should not contain a number. Okay. For example, you can see, sorry, if we create a variable called var and we store a number 7 on it, okay, it will get executed very easily. See, it's got executed. But if we create a variable called 1 underscore var, okay, and store a number certain 8, kind of 8, okay, and we try to run this, this will show you error. This is an invalid decimal sentence, whatever it is showing you, okay. This will basically show you an error. This is not a right way to name a variable, okay. So for the third point, a Python variable name can only contain alphanumeric character and underscore. What this means that whatever the name we are giving to the variable, it should only contain the alphabets, numbers, and underscore. It should not contain any special terms or special digits like asterisk, hashtags, anything. Okay. And the fourth point says variable name in Python are case sensitive, which means that if you are creating two variables like name in lowercase and name in uppercase, this both will be treated as different. Okay, if let's example, take an example, name is equals to Tom. Okay, this is the first variable, and second variable name is equals to Jerry. Okay, and whenever and I want to print my name Tom. Okay, so if I want to print Tom, I need to write print the variable which is containing the name Tom is that one which we have written in a smaller case. Okay, lowercase. So we will write name, and then we will run this. Yeah, it got Tom. But if in this place we have written name in uppercase, then we will get Jerry. Yeah, we're getting Jerry. Okay. So the fifth point would be the reserved word in Python cannot be used to name the variable in Python. Basically, the reserved words means the keywords. We cannot use the keywords to give a variable name in Python. Okay. So about the keywords we will be learning further in more detail. But for now, just understand that the reserved words, which are the keywords, we cannot use it as a variable name. And here are some example of variable assignment. Sorry. Here we are assigning a integer value inside an age, and here we are assigning a float value inside the salary, or whatever you can take the variable name. I have taken a salary, and here we are storing a string value inside a name, variable name. Okay, so you can just write print age or salary or whatever to get to what to see that what is stored in this particular variables. Okay, or either you can just also write type of age. Okay, if I write it like this means I want to print what is the type of my variable, what are the type of data is stored in the variable age. Okay, let's run this and see what the output is. See, the first one we have wrote that type age. So it is telling us what is the type of that particular variable. It is int type. It is containing an int variable, int data. Okay, so it is showing int, and other than that, whatever we have stored in the variables, it is showing that only. Until now, any doubt, guys? Please react so that I can proceed. Any doubts? You can just show thumbs up if you don't have any doubt. Okay, very good. Good. Same. Chalo. So next would be our operators. Okay, operators. So operator, as per definition, an operator is a symbol that perform a certain operation between operands. So चलो लिख के देखते हैं क्या है. ऐसा कुछ बहुत बड़ा साइंस नहीं है, बट ठीक है. 2 and 3 here are the operands, and our plus which we are using over here is our operator, and the performance which is taking place here, that is addition, is our operation. Okay, so there are so many types of operators which we use to do different operations in Python. Okay, the type of operators consist of arithmetic operator, relational or comparison operator, assignment operator, logical operator. So here are the symbols with the picture. You can see arithmetic operators which we have seen from very beginning of our school life. Then here are some assignment operators which you can use. Then relational operators and the logical operators. Okay, so let's see some example. Here we have used the arithmetic operators. Sorry, we have used some arithmetic operators with two variables to see how it's working. Okay, so firstly we will be assigning value 10 to A and 20 to B. Okay. Then after that we will be printing some arithmetic operators, like here we are multiplying, here we are adding, subtracting, dividing, and modulo. Modulo means it will return the remainder. A divided by B करने के बाद जो हमारा remainder आता है, that's what we get using this module function. Okay. And here we use a double asterisk. Double A asterisk asterisk B means that A raised to the power B. This will give us an output of A raised to the power B. And here we have an algebraic term which will be solved, and the precedence order in which it will be solved, I have written in comment. You can see that it will be first. If there is any double asterisk, it will be the first preference, then multiplication, and then division, then addition or subtraction. Okay. So let's just run this and see. Yeah, here you go. Here are the answers to this. There is the multiplication, addition, subtraction, division, modulus, and the power of one, and again that a simplified one. Okay. There are some logical operators like and, or, and not, and I hope you guys have studied it in your 10 plus 12. So still, let's go through this. Our AND operator works similar to as multiplication, and our OR operator works similar to addition. Okay. And NOT is nothing, just whatever the input is given, it will give the complement of the input. Okay. So you can see, as for example, if you give 0 or 0 in A and 0 in B, it will give you 0. And if you give 0 in A and 0 in A and 1 in B, you will get 0. This is kind of similar to multiplying both the inputs. Okay. So that's why I said that AND operator works similar to multiplication, and OR operator works similar to addition. As you can see, if we give an input of 0 in A and 1 in B, it will give us the output of 1. Then for NOT, it's just a complement of whatever you input given. So if you give 0, it will give an 1. Then if you give 1, it will give you 0. Okay. So for next, there is a question I have taken where we are using our logical operators with our Boolean terms, Boolean data types. Okay. So do you guys want to solve this? Do you guys want to answer this? Anyone? Anyone would like to answer this question in the chat box? False. Okay. Anyone else? Anyone else want to try this? Okay, I think no one. Okay, let's try our own. Okay. So how it will be getting solved? See, from the first you will start from here. From the very left side you will start. Not true. Not true will give you what? False. If true, then fine. If not true, then it will give you false. Then false and false. So whatever the answer you get from here is false. And false will give you false. Great. But false and true. False or true will give you true. So I think the answer would be true. And let's check. Yeah, the answer will be true. I hope you understood how I am solving this. You need to start it with the very left portion. Solve this first. Whatever the answer comes, take that answer with this one till this portion. Then solve that. Whatever the answer comes, then solve that with this one. Okay? Clear, guys? Thumbs up, de do jaldi. Okay, good. Okay, let's move forward. So, some example of the relational operators. हमने यहाँ पे relational operators use किए हैं and want to see what this will give us the output. So, we want to print if this condition satisfies or if it does not satisfy, what will be the output. Okay. We guys know that 10 is always greater than 9. So I think this will give us true only. And this will give us false. And this will also give us false. So just learn this. Yeah. This is giving true, then false, and then false. Okay. And some other examples. See, type conversion. What does mean? What I'm doing in this, I am just taking 1 in C. I am storing 1 in C and 2.0 in D. Our C contains an integer value and D contains a float value. And when we sum up that and we want to print sum, okay, what happens in this, the float takes the lead and the result comes in float. That's what I have written over here. Arithmetic operation with integer and float will result in float. Okay, so let's run and see the answer. Yeah, see, it's 3.0. Okay. As I told you guys in this portion that when we are like adding integer and float, we are getting float. So let's take another example. Here we are storing 1 in A and 2 in B, but the 2 is in string format. Whenever we write anything inside the quotation, it is treated as string. Okay, so integer A, A is containing 1, which is in a form of integer, but B is containing 2 in a form of string. Okay, so when we sum up this, what you guys think would be the answer? In which format the answer would come? It will be in string or it will be in int? Good one. Yes, this will show an error. Okay, so for that, to just solve that error, we can do the typecasting. I just wanted to make you guys explain about the typecasting. That's why we say, that's why I used that example. Okay. See, here okay guys, here we are using a typecasting. The same example I am taking here, but here what I am doing, I am just typecasting my B into int. As we are storing a string value in it, I am typecasting into int, and for typecasting we just need to write int parenthesis and the variable we want to typecast, and the variable should be equal to the variable where we want to store after typecasting it. Okay, so we are just summing it up, and here is the exam answer. It was already run actually. We will get 3. So I don't think you guys have any problem till now. So let's go for next topic. Keywords. As I mentioned above, in the variable one, we cannot use keywords as a variable name. So what are keywords? Okay, in Python, there are certain words which are already reserved, which you cannot use as a variable name, function name, or any other identifier. Okay, so that's where the keyword comes into the picture. There are many words like false, true, which you guys have seen. I have taken example, and class, break, continue. You will learn about break, continue in the further concepts. Okay, so there is nothing to know much about keywords, but it's just there are certain reserved words. You cannot use it as a variable name or function name or any identifier. You just need to know this much about the keywords. Okay, and you should know what the words are termed like you are using it as keywords. Okay, so comments. Next topic will be comments. So I'll be taking a very random example that you guys have seen that like celebrities जो होते हैं वो लोग अपने पिक्चर्स वगैरह पोस्ट करते हैं सोशल मीडिया में, तो उनको बहुत सारे कमेंट्स आते हैं, राइट? कुछ अच्छे कमेंट्स आते हैं, कुछ बुरे कमेंट्स आते हैं. सो डू दे लाइक आंसर ऑल द कमेंट्स? नो, राइट? आई होप नो. अगर वो ये करने लगे तो फिर कोई नहीं, मतलब बैठा ही रहेगा खाली सब, है ना? So there are certain comments which they also ignore. They don't feel like answering them. Okay. So that's what comment mean in Python. Kind of similar. Comments in Python are the lines in the code that are ignored by the interpreter during execution of the program. Basically, we have written a lot of comments. See, over here also we have written a lot of comments in our notes. You will be provided with these notes. You guys can go through this. Basically, for better understanding and making our program more readable, we use comments in it. so that any other person who will take this program and read this program will feel easy to read it. Okay. What would the syntax for this? For a single line comment, you can use a hash, or for a multiple line comment, you can use the 3 quotations. Okay. 3 quotations on both the side, and the multiple line comments will be easy to write. Okay. And the next topic will be data types. Okay. So data type will be of 2 types, primitive data type and a container data type. Okay. So primitive data type will contain integers, floats, boolean, none and string. And container data type will consist list, tuple and dictionary. You guys will read it later. But for now, just talk about the primitive data type. Okay. Integers contain the positive, negative digits with 0. Okay. And float contain the decimal digits. Inside boolean, we have two outputs only. Either it's true or it's false. And string contains the words or the sentence inside the quotations. These are the 3 quotations we can use for storing your string value. Sorry. And there is a none data type. This is used where we don't want to store anything. Okay. This is just to specify that this variable is containing a null data type, nothing else. Okay. Sorry. Here are some examples I have taken for boolean. Excuse me. Okay, so here are some examples I have taken for the boolean. I have stored a true value in A, and I want to see what is the type of A. Okay, it's already showing the answer. Okay, and I have stored a value false in B and want to see the type of B. Okay, so it is very obvious what it will show. It will show that it is a boolean data type which is stored inside the variable A and B. And here some examples. Sorry. So I have written when x is not equal to y, it will return false. Simply if we are using any relational operator and want to see if the relation doesn't satisfy, it will give you false. Okay. So I have assigned a value 5 to x and 10 to y. And we want to print the boolean expression which is giving whatever the output gets in a boolean expression. So it will give us false. Okay. And same for this too. See, I have stored a none value in x and an empty set in x. Okay. Empty value in x. This both will give you false. In both the condition you will get false. But if there is already something stored in a variable and you want to see what its boolean type, then it will give you true. Okay. Yeah. See, this 3 is showing us false and the last one is showing us true. I hope there is no doubt till now. You guys can just show a thumbs up. Okay, good. Very good. Okay. So our next topic will be input and output. Okay. So for input, I will go for the input function. For output, we know we have already studied it on the very first only. That print function. For output, we can use the print function. The definition says the same, very basic. Print function prints the output on the screen. And here I have taken some example for the various ways of printing. This is very much understood. We have used it very first example. We used it the same way. For the second one, if I want to like print something in a one statement, okay, like the statement should be, hello, my name is this and my age is this. Okay. Sorry. So I can use name variable and store the name, and use the age variable and store the age. and print it in a way like whatever you want to print, it should be in the quotation, should be inside the quotation, and then the variable name, and again the thing which you want to print after that should be in quotation, then variable name, then again the quotation. Okay. So let's just run and see what is getting. Yeah, see. Hello, my name is Alice and I am 25 years old. This is what we are getting the answer, and that's what we wanted. And the next example is if you want to print something, that complete sentence you want to print, but you want like up to this word, it should be printed in a one line, and after that word, everything should be printed in the next line. Then you can use this \n. Okay. As I have written, SAE welcomes you all in our ML workshop. But I want that after the all, everything should get printed in the next line. So I am using this \n over here. Okay. So let's just run this and see. Yeah, see. Everything after all is getting printed in the next line. Okay. So now the input function. About the definition, input function is used to take user input. Like we know for output we are using print function. Whatever we want to show in the screen, we are using the print function, output function. Okay, print function. So for input, for taking the data from the user, we will use the input function. And by default, whatever the data we are taking from the user by using the input function, it gets stored in the form of string. This is important. You should remember this. And the syntax for it will be just write input, then the parenthesis, and whatever you want to ask the user, that what is the color of the rows, or whatever you want to ask the question to the user, by which they can understand, give you the input, write it inside the quotation and store that value in any variable. Okay. So here is an example which I have taken. Let's just run it and see before that. Okay. So this is getting stored in the string format, and it's a question, so it's fine. Whatever the answer will be string, it's good. But in the next one, I am asking how many roses. But if I want to store it, like how many roses, it will not say FIVE 5, right? So you will be using any numeric term. So we will be wanting that the data to stored in an integer format. So we are just typecasting it over here. See, before input, just write in for typecasting it. Okay. And same as for this, we are typecasting it in float. Okay. Let's run this and see once. What is the color of rose? Red. Yeah, it's printing red because we have written over here print color. Whatever the value is stored inside color, just print that. Now, how many roses do you want? Let's say 5. Okay. Now the price of each rose. Okay. Whatever we will write, let's write 6. Okay. I am giving an integer value, but I have already typecasted it into float value. So whatever I am giving, it will give me the output in a float variable. Okay. Yeah. See, our output to this is in a float format. Okay. I hope there is no doubt in it. So next example and the last example, I guess. Yeah. So in this also we are doing the same thing. We are just taking an input of a name and an age. We are just printing it. Okay. So I just want to ask, if I am writing this statement, type of age. Okay. Let's just comment this out first and run the program and see what's coming. Okay. Okay. I am just running it. Yeah. Any name, let's say Ram. Okay. Its age 15, and it will be printed like this. Okay. But what if I ask this question to print the type of age? What you guys think it will show? Will it be show integer or it will show a string? Answers, guys? Any guesses? Anyone would like to answer? Okay. problem. Let's run and see. Same thing, round, page 15, and see. It's printing whatever we have stored over the variable. Now it will show that it's class string because I have said it earlier that whatever the input we are taking from the user, by default it gets stored in the form of string. But if you guys might wonder that its age, how it's getting stored in string, you can also typecast it in int. Okay, but by default, whatever you take input from the user, it gets stored in the format of string. I hope there is no doubt with this. Okay, great. Thank you so much. And that's it with my part. For the further concepts, I would like to call up my fellow teammate, Vinayak. He will tell you about the loops. Okay, thank you.
Hello, myself Vinayak. अभी actually hello. Hello everybody. We are now wrapping up the session. आज हम लोगों ने बहुत सारे theoretical parts पढ़े, ML, DL, ANN, CNN, basics of Python, data types. All of these were a bit theoretical part, but कल से main part start होने वाला है, जो कि model training है, and which is very interesting. So please join the workshop tomorrow to learn how to create your own model as well as deployment. और आगे यूरो का पार्ट भी आने वाला है, जो कि और भी ज्यादा मजेदार है. आप में से किसी को अगर कुछ डाउट हो तो आप अभी पूछ सकते हो, और आज का मटेरियल्स भी दे देंगे हम लोग.